Oh, everybody's favorite function, y equals e to the x. The derivative, dy dx of e to the x is e to the x. Now, someone in math classes today said, I love how math is so random. This isn't random at all. We know e is Euler's number. It's about 2.71828. Or if you remember, it's about 2.7. That's fine. If we take e to the x, look, our base is greater than 1. That's exponential growth. Looks like that. If I put in a 0 for x, I get 1. So this is the point 0, 1. Now, let's think about what our tangent lines will look like. Here, our tangent line is positive. Here, the slope of our tangent line is positive. Here, the slope of the tangent line is positive. If I graph 0 slopes there and positive slopes above and negative slopes below, I know this is a tough concept, but that's one of the most challenging concepts we will have this year. Notice all of the slopes are positive, so I will graph them all above. Well, the slope right here, take a look, right at this point, 0, 1, our slope is about rise over run, 1 over 1. So if I'm graphing the slopes, I'll also get that point right there. Look, notice this slope, if our x is right here, look at our slope at this point here. Looks like it's like, I don't know, 9 over 1. And if I graph that point, I'll get this point right here. And if I continue to do that, if I graph the derivative on top of the original function, the red one being f dash of x and the purple one being f of x, which was given as e to the x, well, we'll see that the derivative is right on top of it. It's also e to the x. It's not random at all. If we do some problems with the world's favorite function, look how easy it is to find the derivative. F dash of x is the same thing. Given e to the x, we get e to the x. If the function is negative e to the x, then the derivative is negative e to the x. If the function is 405 e to the x, then our derivative is, you guessed it, 4 over 5 e to the x. If the original function is 5 e to the x, d dx means take the derivative of it, we'll get 5 e to the x. If the original function is negative 5 e to the x, d dx means take the derivative of it, we get negative 5 e to the x. And finally, if we have negative 1/3 e to the x, the derivative will be negative 1/3 e to the x, or you could just write it as e to the x over negative 3. So easy, so fun.